In number 1, it tells us that ray PR bisects angle QPS. So the first thing I'm going to do is go ahead and draw that angle. So I'm going to have any angle when you're drawing this. So I have P will be the vertex. So Q is up here, P is down here at the vertex, and then S. And then it tells me that I have ray PR. So remember, you're trying to make it look like there's an angle, or that it's cutting the angle into 2 equal parts, because it is an angle bisector. So P, and then this will be R. So I know that these 2 parts have to be congruent. So now it says the measure of angle QPR. So QPR is 1/2 y minus 3. And then it says QPS, so this entire angle is 16 minus y. So the whole thing is 16 minus y. So the first thing I know is that since I have an angle bisector, we have 2 congruent parts. So an angle bisector implies 2 congruent angles, or 2 congruent parts. So if this piece right here is 1/2 y minus 3, well, so is this one. They have to be equal to each other. And in this problem, I'm not going to actually set these equal because it's the same expression. So if you set the same expression equal to itself, everything will just cancel out. So instead, I need to use this 16 minus y. So the fact that I have an angle bisector is telling me that these 2 parts are equal. But now, since I have 2 parts and I know the whole thing, I'm actually going to apply the angle addition postulate. So once you have your angle bisector, then it's going to be now apply the angle addition postulate. And remember what that says is that part plus part equals the whole thing. So that's actually going to be how you're going to solve this. So part plus part equals the whole. So you're going to have 1/2 y minus 3 plus 1/2 y minus 3 equals the whole thing. So like I said, this one you're not setting the 2 pieces equal because it is the same expression. In order to be able to set the 2 pieces equal, they have to give you 2 separate expressions, like the last example. In this case, you added that expression in there. They're the same. So you're adding them up to equal the whole thing. And now we can solve. So for this one, you could multiply everything by 2 to get rid of the fraction. But since we're combining like terms, and if I have a half plus a half, it's just going to equal 1. It's just going to be easier just to combine them. So I have 1y minus 3 will be minus 6 equals 16 minus y. And then from there, you can bring the y over, bring the 6 over. So I have 2y, these cancel, equals 22. Divide by 2, we get y equals 11. So there's my y value. But now the question actually asks you to find the measure of angle QPS. So off to the side here, I'm going to find the measure of angle QPS, which is the entire angle QPS. So I'm going to plug in for y. So the measure of angle QPS will be 16 minus 11, so it'll equal 5 degrees, which doesn't really seem like that picture is drawn to scale, but like I said, you don't know what your angle measure is going to be until you solve the problem, so you don't need to worry about your pictures being drawn to scale. Example 2, or practice problem number 2, you have lots of information here, so let's start with just labeling. So CD bisects ACB. So CD is bisecting ACB. So that means these 2 parts have to be congruent. And then I have AE is bisecting CAB. So this whole angle, so that means these 2 angles are congruent. Then it tells me some measurements. So ACB, so ACB, this entire thing is 48. But if I have a bisector, if I divide 48 by 2, that gives me 24. So that means each of these is really 24, since it was being bisected. CAB, the whole thing's 56. So if we take 56 and divide that by 2, because it was an angle bisector, you're going to get 28. So each of these is 28. So again, because I had these bisectors, angle bisector implies 2 congruent angles. That's the reason for what I just did. So now we have 4 different things we're going to find. So I'm just going to number these. And we're going to just find them one at a time. So the first one is the measure of angle CFA. So if I look at the measure of CFA, it's this angle right here. So the first thing that I see is that this is the third angle in this triangle right here. So we haven't really talked much about triangles yet, but hopefully you remember that in a triangle, all 3 angles have to add up to 180. So if I just write that out, so in a triangle, all angles add to 180. That's my reason. So that means if I just subtract those 2 angles from 180, or add them up and then subtract them from 180, same thing, you'll get the measure of that angle, which is 128. So CFA is 128. So then the next one, so this is 128. Next one is EF. So EFD is this angle right here. So if you look, I have an X. These are vertical. So for number 2, that one's easy. You don't have to do any calculations. That's just going to also equal 128 because those are vertical. So vertical angles are congruent. So that's 128. And then the last 2 here, so we have the measure of angle AFD. So AFD is this. I'm just going to put a star there. These 2 angles, 128 and AFD, form a straight line, so those have to add up to 180. So I can just say a linear pair implies that the angles add to 180. So I have 180 minus the 128, which gives me 52. So that one's done, and then the last one, the measure of angle CFE. So CFE is this angle. Well, now those 2 are vertical, so if this is 52, this one's 52. So we know that that's 52, and then you just write your reason. Vertical angles are congruent.